Hey folks, part 3 of our second lecture 1.2. So we're just going to start off, jump right to a question. What kind of measurement is 3.5 DL? And here are your options. So you can pause it, answer for yourself, and then come back and I'll walk through it. Okay, so the key here is just looking at DL. And the little d tells us right away we're talking metric system. Even if you don't remember what that is, it's deci, by the way, but even if you don't remember that, you know that it's not one of these, right? So then what's left is it mass or is it volume? And so the D in the front tells us that it's metric, and then the L we have to recognize as liters, and that's a volume unit. Okay. If it was metric mass, by the way, we would expect to see something like um, dg. Now, dg is not very common for various reasons, but just as a unit, we don't use decigrams very often, but it doesn't matter. Remember that you're just looking at the base. It would be grams if it was mass. It'd be liters if it's volume. And that's a giveaway. Okay? Now, we walked through that one. Here are a few more going similar idea. This is practice exercise 1.8 from your text. Are these English or metric? And are they length, mass, or volume? So go ahead and pause and answer. And now I think you're back. So I'll show you. We're just going to populate the answers and we'll talk about it if needed. There we go. Point 0.5. Also get some practice with these names. So this is the Greek symbol mu. It's kind of like a U with tails. Then it's called mu, and it's micro. So it's zero point 0.5 micrometers, or sometimes we call it micron for short, but that's metric, of course, and length. The B, 6 gallons. Gallons is an English unit. If it was metric, it'd be something with liters, right? So gallons is English volume. 100 kilograms, metric mass. 8 centimeters cubed is metric, but it's volume. So it could be, remember, a milliliter is equal to a centimeter cubed, or a cubic centimeter. It's still derived from metric. E, 125 lb. Well, just because it's two letters, that doesn't mean it's metric, right? The L is not a prefix of something. B is not a base unit. LB is just the strange abbreviation for pound, right? So it's English weight. There is a difference between mass and weight, but I'm not going to get into that quite yet. And the last one is 0.6 milliliters metric volume. Cool. Like I said, that's from your textbook, Practice Exercise 1.8. Okay, the last kind of thing to introduce here is density. Density is one of those derived units, but it's fairly common, so we're going to spend just a few moments on it. Density is defined as mass over volume, right? How much something weighs, or the mass of it divided by the space that it takes up. We would abbreviate it as D equals M over V. And notice that we have a lowercase m, not meters. In this case, it stands for mass. Context matters. There's only so many letters, Greek letters, symbols, that often they are used for multiple things. So M on the last slide meant meters, and M here means mass. And you can tell by the context, right? So what else is going on with the question? So if we have D equals M over V, here's our first chance to look at a mathematical relationship and I would say manipulate it or rearrange it, right? So um, these are just variables holding place in this equation. D equals M over V. If you wanted to solve for M, keeping variables, right, we could do that. What would M equal? If you wanted to get M by itself, right, we could take our original equation, multiply both sides by V. Notice that V would cancel out and you'd have M by itself over here. So M would be equal to density times volume. If you know the mass of something and you know the density of that object, you were wanting to know what the volume would be, we can also solve this set of relationships for volume. We could do a similar thing. Now, I think I wanted to remove these. There we go. If I was solving for volume, right, I could take here and divide by D on both sides, and the D cancels out. And so volume is equal to mass over density. Okay. So really just one thing you could say is given any two out of the three variables, density, mass, or volume, you can find the third. And we can actually do that with the equations without even needing numbers yet. So I want you to try to start thinking like this rather than plugging in numbers and trying to just go on the fly. Set up the equations initially. So now we have three different equations. One that solves for density given mass and volume, one that solves for mass given density and volume, and one that solves for volume given mass and density. So if we look at this first question right here, an aluminum sample has a mass 14.8 grams and it displaces 5.48 milliliters of water. What's the density of aluminum? This is how you might go about finding that experimentally. So which two variables are given or known? We know mass at 14.8 grams, and we know volume at 5.48 milliliters. And what's the density? Then that's what we are supposed to find. So D is the unknown. So we're going to take the equation that solves for D. Mass over volume. So we have 14.8 grams divided by 5.48 milliliters. So we punch it into your calculators and we get 2.70. And now what do we do with the units? Well, the units of density are grams per milliliter. Remember, this is one of those derived units. It's a ratio. And you can write it as just like this, grams G/ml. Another way that you could write it is as 2.70 grams over milliliters explicitly. But a more common way is right here. Here's another question. Guess the pattern of these questions here. Ethanol is a common laboratory solvent with a density of 0.789 grams per milliliter. So we know density. What is the mass in grams of 100 milliliters of ethanol? So 100 milliliters is volume. We don't know what's the mass of that volume. So looking at our equations, if we want to find mass, it's going to be density times volume. And now I'm going to actually write it as a fraction. there's my density, 0.789 grams per 1 milliliter, as we've talked about. Right, you could leave the 1 off if you wanted. It's implied, but I'm going to put the 1 there. And now times 100 milliliters. And the reason it's helpful to write it like this is because now we can see quite clearly milliliters will cancel because we have it on the bottom of the fraction and then in the measured quantity. And what we're left with then will be something in unit of grams, which we want mass, so that's good. That's the correct unit. And we get 78.9 grams. I have one more question. Guess what it's going to be? What volume of ethanol in milliliters has a mass of 25 grams? Okay, so same questions before with ethanol, or same substance. So we know the mass. Because it's ethanol, the last question, we know the density, and we're supposed to find volume. And so here we have V as what we're solving for. And we go to mass over density. All right, so the mass is 25 grams. And density is 0.789 grams per milliliter. Let me think how we want to write this. Remember that density is like a conversion factor. If we're going to divide by density, it's the equivalent to multiplying by the reciprocal or the inverse. Right, so we can write it like this. And if I'm going to divide by that, also remember I said let the units guide you. We can flip it. This is still like dividing by the value of density because this is on the bottom, but it helps us with the units to write it like this. We see grams and grams cancels out, and we'll get something left over in milliliters, which is what we want, as volume. And so we take 25 divided by 0.789, and we get 31.7 milliliters. So the cool thing here, think about if you didn't have this equation right here for volume, but all you had was the mass and density of something, and you wanted to find volume, you could look at the units and realize there's only one way to put this problem together that gives you milliliters, and that's if you flip the density as we did here. Right? So letting the units kind of guide how you set up a problem can be helpful. All right, that's it for this one. So this concludes lecture 1-2, section 1-2 on units and measurement. Thanks for watching, and check out the post-lecture questions when you're done.